Welcome to Chapter 1, Looking at Data, Distributions. We're going to be looking at, in Section 1.1, displaying distributions with graphs. In Section 1.2, we're going to be describing distributions with numbers. And in Section 1.3, we'll be looking at density curves and the normal distribution. So let's take a look at Section 1.1, displaying distributions with graphs. We're going to pick up some definitions so that we all are on the same page as we're going through our statistics course. Now, first of all, what is statistics? It's a science that involves the extraction of information from numerical data obtained during an experiment or from a sample. It involves the following: design of the experiment or sampling procedure, collection and analysis of the data, making inferences or statements about the population based on information in a sample. So, statistics is the science of reasoning with data. It's a science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. And right there you see how that fulfills your Gen Ed requirement for quantitative reasoning, because that's exactly what quantitative reasoning is. Analyzing that data to draw conclusions and answer questions. So let's take a look at collecting data. First of all, you have to have a question, and you have to have a group of people or things that is going to answer that question. So you have individuals you can go to in that group. We call it a population, the collection of all people or things that could answer the question. With each individual, there will be a variable or variables that will help to answer the question. What we need to do is we get these variables, examine distributions of the variables, then we learn how to look at these or to graph. And we learn graphs for categorical variables, those are bar graphs and pie charts, and graphs for quantitative variables. And we're going to look at the histogram, stem plots, and time plots. Now there's a lot more, but these are what we're going to look at in this section. So as I said, what is an individual? It's the group we go to answer a question or questions, and we can collect data needed from this group to try to answer a question or questions. So it's the objects described by a set of data. It could be people, animals, or things. A variable is a characteristic we are specifically looking at to help answer questions and or collect data that is needed. There can be more than one variable that will help us to answer the question. So it's a characteristic of one of the individuals in our study. Any characteristic of an individual, it can take different values for different individuals. So let's take a look at data. Now, statistics is the science of reasoning with data. And data is the collection of values of a set of characteristics for a set of individuals, collected for a particular study. So we're going to look at this particular study. They want to know the first and last initials, the gender, state of birth, number of years with present employer, and the profession. So you give this survey out to a bunch of employees, and you have them answer the question, and you collect data. And the data will look like this. A bunch of letters and numbers it's hard to make any sense of, and that's why we have to take these and we have to find ways to represent it so it's readable and we can do some analysis on the data. So individual, object or subject of an experimental unit is the entity in which information is collected. Again, we've talked about that, and now we look again at a variable. It's the measurement or characteristic of interest for an individual. For example, the name, address, customer number, and so on. An observation in our data set, it's the set of all the measurements, that is, variable values collected from a single individual. So you look at a single observation, it's the row, and the column is the values for a particular variable. Statistics it involves the collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. What's a population? Well, it's a group to be studied and includes all the individuals in the group. A sample is a subset of the population. It's often used in analysis because getting access to the entire population is somewhat impractical. Now, there are two types of statistics, and this is important to know. Descriptive statistics. That's statements about the sample, the organizing and summarizing the information collected. And then we have inferential statistics. Generalization of the sample results to statements about the population. So we're going to start to explore data. We'll begin by examining each variable by itself. Then we move on to studying the relationships among variables. In Stat 250, we're basically just going to be examining the variable by itself. Begin with a graph or graphs, then add numerical summaries of specific aspects of the data. The process of statistics. There's 4 steps. First, identify the research objective. What's our question? What questions are to be answered? What group should we go to be studied to answer those questions? Step 2, collect the information needed. Can you access the entire population? How can you collect a good sample? What other methods are available and appropriate? Step 3, organize and summarize the information. So we have descriptive statistics, visual methods such as charts and graphs, and then you have your numerical methods such as calculations. Step 4, draw conclusions from the information. That's inferential statistics, with various methods that are appropriate for different questions and different types of data sets. Qualitative versus quantitative variables. Categorical or qualitative, what are those types of variables? Well, they're variables whose values are attributes or characteristics. It allows researchers to categorize the individual. And quantitative variables, well, they're variables whose values are numerical measures that arithmetic operations can meaningfully be performed on. It allows researchers to summarize via averages. Now, there are 2 different types of quantitative data or quantitative variable. You have discrete variables and continuous variables. Discrete variables, well, they're variables that have a finite or a countable number of possibilities. Often these variables are counts of things, so you can count 1, 2, 3, 4, 5. The continuous variables that have an infinite, not countable number of possibilities. Often these variables are measurements or ranges of values. Descriptive statistics. What is it? Well, after we collect the raw data from a sample survey or a designed experiment, the visual methods we're going to study in section 1.1 and the numeric methods we're going to study in 1.2. Different methods are appropriate for different types of data. Now remember, descriptive statistics are statements about the sample. The focus is on interpreting and presenting data that has been collected via a sample. No attempt is made to generalize to the larger groups, such as the population. Let's look at a case study, the effects of hypnosis on the immune system. The objective of this study was to determine if hypnosis strengthens the disease-fighting capacity of immune cells. In the case study, they had 65 college students. 33 were easily hypnotized, 32 not easily hypnotized. They took their white blood cell counts that were measured, and all students viewed a brief video about the immune system. Now, students were randomly assigned to one of these 3 conditions. Subjects hypnotized given mental exercise, subjects relaxed in a sensory deprivation tank, and a control group, no treatment. White blood cell counts were remeasured after 1 week. The 2 white blood cell counts were compared. The result was hypnotized group showed a larger jump in white blood cell counts, and the easily hypnotized group showed the largest immune enhancement. In this experiment, you can see that we have our categorical variables, easy or difficult to achieve a hypnotic trance, the group assignments, and the quantitative variable was the pre-study blood cell count, white blood cell count, and the post-study white blood cell count. Well, we have the study of weight gain spells heart risk in women. The objective of this was to recommend a range of body mass index in terms of coronary heart disease risk in women. They took 115,818 women, ages 30 to 55, without a history of coronary heart disease. They weighed the woman, their body mass was determined, and each woman was asked her weight at 18. They followed this group of women for 14 years, and the center of disease and the coronary heart disease, 1,292 cases were seen in the 14-year period. We can look at the quantitative variables, the age, the weight at 1976, and the weight at 18. Categorical variables are the incidence of coronary heart disease, whether they were a smoker or non-smoker, family history of disease. Now this ends part 1 for section 1.1. We'll continue in the next installment. Thank you.